Okay, hello everyone, and welcome back. This is the third video of this series, and finally, we are going to be doing something a bit more challenging. This is going to be a 4 unit question. Okay, so if you're not doing 4 unit, you don't have to worry about this video. But if you're currently doing 4 unit or you want to do 4 unit in the future, maybe this video will be a little bit interesting for you. Although it is a harder question, so if you haven't really learned the basics of these questions, will be complex numbers. If you haven't learned the basics of complex numbers, I'd recommend you go over that before attempting this question. It's not an overly difficult question, but it is a bit of a step up from your normal question. Okay, so the question which I have today, we have stolen, not really stolen, but borrowed from the North Sydney Boys, North Sydney Boys 2018 HSC trial. Okay, and which question am I borrowing? It is going to be question 14B. Okay, I'm going to give it back. That's why I'm borrowing it. All right, so let's have a look at what this question is about. I am going to write the question onto the paper, and then maybe you can have a look at it and have a go at it, pause the video and see if you can work through it. And if you can't get it, then unpause the video and I will go through it. Okay, so let's get started. So this is going to be a complex number question. Okay, so let's get our blue pen. Okay, so complex numbers. Okay, so the prerequisite knowledge. All you need to know for this one is complex vectors. Complex vectors and basic complex number algebra. So you don't have to be too far into the complex numbers topic. This is about not even halfway in, probably a third of a way in. Okay, so as long as you know these two, we should be good to have a go at this question. Okay, right. So let's draw up a diagram of the question first to have the situation shown. Okay, so I, y, x, this is the Argand diagram. We have the point P, we have a point Q, and we have a point R. Okay, now Q is represented by omega or W, and P is represented by Z. Okay, so right, just in brackets here, so we can see this will be W, and R is going to be giving us P R is equal to W plus Z. Okay, and this is a parallelogram, as we know from our parallelogram rules. Okay. I will be making some assumptions, some basic assumptions and reasoning I will not go over in this video. So if you are not quite understanding a step, maybe go back and revise through your complex number notes and come back when you understand that particular concept. Okay, but I won't skip too much, hopefully. So we should know that if we add two complex vectors together, the sum of the complex numbers will form a parallelogram with the original two. Okay, so this will form a parallelogram. So we should know that at this stage. All right. So far so good. And then we also want this to be alpha, and then we call this O. Okay, so angle OPR equal to alpha. Okay, so make sure you copy this diagram down if you are working along with this question, okay, because you will need it. Just going to scroll up and it's going to be off the page. All right. Okay, so our first part, again, feel free to pause the video and have a go at it on your own and then come back and look at the answer if you need. Arg, okay, I'll do it in a different color so we are sure that's a question. I show that arg omega on z is equal to pi minus alpha, okay, and this is worth 1 mark. Okay, so have a go at this question and pause the video here. All right, so if you have paused the video and now you're back, or you didn't bother having a go at it, which is fine as well, I understand. Maybe you just want to see the answer, excited to see the answer. Let's do this question. Okay, so arg W minus Z. So we should know that arg W on Z can be simplified into arg W minus arg Z. It's just like the log laws, okay? Which is basically just the difference of here, okay? So we are basically looking at the difference in the arguments here, okay? And we also know that this is going to be just the angle in between these two vectors, okay? So that's going to be giving us this angle here. So this is going to give us the angle POQ, okay? So I will write that in here. This angle here is arg, goes this way, W on Z. Okay, fantastic. So that's POQ. And how do we get POQ? Well, we know that angle POQ plus angle, now we're going to add this angle here, which is angle OPR, that's equal to 180 degrees, as adjacent sides in a parallelogram are supplementary. So they add to 180 degrees. Okay. And then let's convert all this. So angle POQ, which is equal to arg omega on Z, is equal to 180 degrees, which is pi, minus this, which is equal to alpha. So minus alpha. And that's our answer. Okay. Now, let's do part 2. Part 2. Okay. So hence, this is not hence, sorry. Use the cosine rule to show that the modulus of Z plus W all squared is equal to the modulus of Z squared plus the modulus of omega squared plus 2 times omega Z modulus multiplied together, cos arg W on Z. Okay, so this is worth 2 marks. Again, if you want, pause the video and work on it here. If not, let's jump straight in and go through it. Okay, so Z plus W all squared. Well, this is a fairly straightforward question because it tells you to use the cosine rule. Okay, so we know that we want to find which one is Z plus W. Okay, so that would be this case here. So we're actually looking here. So Z plus W. So we know that we are probably going to be doing something with this side over here. Okay, and with this angle involved here. Okay, so let's write out the cosine rule for that triangle. Okay, so I'll bring it down here so we can see that triangle. Just draw the triangle on its own. We have Z. Okay, we also need to remember that because this was omega, that this is going to be omega 2. Okay, and this is Z plus W, and this was alpha. Okay, so let's do our cosine rule. So we take the long side here as the Z plus W modulus squared. Okay, that's equal to 2 times modulus, jumped ahead there, modulus of Z squared plus modulus of omega squared minus 2 modulus of Z times modulus of omega times cos alpha. Okay, so far this looks a little bit different to what we want. Okay, we want a positive this, but for some reason it's not right. Okay, so we can start that by fixing this inside here. Okay, so instead of alpha, we want this. Okay, so this, we have alpha here. Okay, well, we can look at this equation and rearrange this. Okay, so what is alpha? Alpha is actually just pi minus this. Okay, we can just exchange these two in this statement over here. Okay, so that gives us Z squared plus omega squared plus 2Z omega cos pi minus arg W on Z. running out of space there. We'll write the equals a bit more across. And we know that since cos in the second quadrant, basically this is saying it's a second quadrant expression angle, then it'll become the negative version. So it'll be negative of a negative, which changes it to positive. Okay, so that's perfect. That will give us what we want. So z squared, omega squared. Now this minus becomes plus 2 times z w cos arg w1z. Okay, which is what they wanted us to do. Okay, now let's have a go at the third part. Okay, hence, or otherwise, show that cos arg w on z is equal to z plus w modulus all squared minus w minus z modulus all squared on 4w times z. Okay, and this is going to be worth 2 marks. All right, so pause the video and have a go at it. All right, and if you are back rejoining us or you didn't pause the video, let's go through this question. So before I just jump ahead and tell you right away how to do it, I'm going to explain, if you didn't get it, like what are the clues that a lot of challenging questions, I like to sort of tell students, well, what sort of hints should we be looking for in the question that might have given us an idea of what was a method that they wanted us to do, right? Because, I mean, it's easy enough for me to say, okay, just do this method and you're good to go. But it's a different thing altogether to actually come up with, actually think of that method in the spot. Okay, so let's look at some of these hints. So it's a bit messy right away. There's these weird expressions, it's complicated. You don't know what's going on, don't know where to start, okay? But we look really carefully at the question and we see that we have a w minus z all squared in this expression. And we also have 4 omega z. So it looks a little bit similar to this, right? But we have this extra w minus z coming out of nowhere, and we have this wz, this 4 coming out of here. Okay, so what this might tell me, okay, is maybe I want to look at this w minus z on our diagram. Okay, so I'm just going to draw that up. So we have, this was z, this was omega, and we have w minus z, which is z to omega. Okay. Z minus w. Sorry, that was the other way around. W minus z. All right. Okay, cool. So now that we know we have this triangle set up, we can maybe think, okay, what might we want to do? What was this again? This was arg w on z. Okay, well, now that I've drawn it out here, remember, always try and draw out your working out. It helps, okay? Especially when you're doing this geometry style question, even like isolate it from the rest of this picture. Okay, so in here, right, there's too much going on. It might draw your attention away from what's important. If you just draw it out on its own, it might become a lot more clear what we're after. Okay, now drawing this out, it's sort of clear. It might not be clear to you, but it's clear to me that maybe I should try cosine rule with this. Okay, cosine rule with this side. Okay, and then that maybe will give us this value, and maybe it will give us another omega z. Okay, and it will also give us this value over here. Okay, so let's try that. Let's do the cosine rule here. Okay, so what we'll have is omega minus z squared is equal to omega squared plus z squared minus 2z omega, and then we'll have cos arg of w on z. Okay, now that's one thing we have sorted, but we also have to remember another hint that it's a hence or otherwise question. Okay, generally when there's a hence or otherwise question, hence means use the previous part. Okay, so we want to have a look here to see, okay, well, we have this and we have this from the previous part. What can we do to make this look like this? Okay, well, from what I can see a z plus w squared minus this, okay, which is a bit of a giveaway as to what to do. Okay, and I can also see something to do with this. So this looks very similar to this as well. Okay, so the first step to start maybe is just to make this expression here and then rearrange it, and then maybe we can get it into this form in total. Okay, so let's do that. So let's label this equation here as 1, and then label this equation here as 2. And then we are going to write out 1 minus 2. So let's write that out. That's going to give us w plus z all squared minus w minus z all squared. That's equal to, and then what we'll have here is we'll actually have these terms cancel out, okay? Which is looking good because I don't see those terms in here, okay? I don't see this or this. I don't see that there, so it's good. We want them to cancel out. So cancelling those out, we have nothing there. And then we will have this expression left, but this becomes a positive because now it's minus a minus, so it becomes a positive. Okay, so we'll have 2zw cos arg w on z, which is from the first part, and then we will have an additional version, which is from the second part, which is from equation 2. Okay, and then putting that together, we have 4. Okay, we see our 4. This is on the right track. Cos arg w on z. All right, and then now once that's sorted out, we can rearrange it for what they want. Okay, so they want the cos arg w on z to be on its own. So we'll give them that. Therefore, cos arg w on z, that's equal to w plus z all squared minus w minus z all squared on 4 modulus of z times modulus of w. Okay, and that is what we want as the answer. Okay, fourth and final part. If alpha is equal to 7 pi on 12, the modulus of PR is equal to 2, z is equal to 3 cis pi on 4, find z plus w in Cartesian form, right, which is the x plus ry form. In is Cartesian form. And this is worth 3 marks. Okay, so pause the video here, have a go at it. Okay, and if we are back, let's go through this question. Okay, so let's find out what we need to know. We need to find arg z plus w. Well, we already given z, so z is easy. We just have to find out what is w. Okay, so what is, or omega? What is omega? Okay. All right. So we can simply find out omega by looking at what is the argument, look for the modulus, and then look for the argument. Okay, so we want to work out both these things because there's no way we can get omega in Cartesian form right off the bat. There's nothing to give us a hint there at all. So I'd be imagining that we're going to be looking for this in mod arg form. So what is the mod of omega? Well, the modulus of omega is just simply equal to the length of OQ, which is the complex number that it represents, okay, or the length of the parallelogram that it represents, which is also equal to PR, magically, okay? And, well, they tell us what PR is over here, so we can say that that is equal to 2. Okay, so that's sorted, and we'll put this equals here. Now, what is the argument of W? Okay, so, well, they give us alpha, and that's really all they give us, okay? But we can use what we learned previously, okay? So we know that arg W minus arg Z, which is arg W on Z, that was pi minus alpha from before, minus alpha. And they give us the alpha is 7 pi on 12, so pi minus 7 pi on 12. And then now, all we are after is, what is the argument of Z? Okay, well, that's pretty simple because Z is just cis pi on 4. So pi on 4 is the argument. We just throw that in, minus pi on 4. Okay, and then now that we have that, all we have to do is simplify this expression. Okay, so arg W, get arg W on its own, is pi minus 7 pi on 12. This should be a 12, plus pi on 4. Okay. And then let's simplifying this down. What does that give us? It gives us, let's do a bit of quick math over here. So we will have 5 pi on 12 left. So 5 pi on 12 plus pi on 4, which is going to be 3 pi on 12. So this gives us 8 pi on 12, which is equal to 3 pi, or 2 on 3 pi. 2 pi on 3. Okay, so that's our W. So we now know that therefore omega is equal to 2 cis 2 pi on 3. Cool. Now all we have to do is add them up, or put them into Cartesian form, add them up, and that gives us the answer. Okay, so Z plus W will give us 2 cis 2 pi on 3 plus 3 cis pi on 4. Okay, I wrote them in the backwards order, but it's the same idea. So that's 2 times, and then we want cis 2 pi on 3 in Cartesian form, okay, which is minus half plus I root 3 on 2, and cis 3 cis pi on 4, which is 3 times 1 on root 2 plus 1 on root 2i. And we will simplify that so that all the real parts are together and all the imaginary parts are together. So that gives us minus 1 plus 3 on root 2 plus I root 3 plus 3 on root 2. And that is Z plus W in Cartesian form. If you really want to at this stage, you can rationalize the denominator here, times everything by, to have everything on 2 instead of root 2. But at the end of the day, it should not make a difference in this question. Okay, so that was it for this question. Hopefully it was not too difficult and you were able to follow along. If not, make sure you go back and revise on any of the basic concepts if the steps aren't really linking up here for you. Okay, so that's all for this video. Thanks for watching and hope you guys learned something new.